Prof. Sir.
Okay, thank you very much and welcome to today's lecture. I recall that we began yesterday talking about air quality standards, and we began with the definition of air quality management, which we said a regulatory authority sets out to ensure that people and the environment are protected from the harmful effects of air pollution. And this is done to ensure that human activities, human endeavors, the aspirations of people do not negatively affect them and then the environment in which they live in. We move to the air quality management set, who always talks about establishing goals, determining how much emissions you will reduce. We went on to talk about the control strategies that have to be in place to keep the emission reduction targets in place. Then you implement what you have set out to do and you do an evaluation. So we began yesterday, we ended yesterday when we began looking into each of these components of the air management set. And the first one is to set air quality goals. We said air quality goals must be realistic, they must be time-bound, they should be achievable, they should be measurable, and you should be able to quantify it. And all of this must be informed by science. That means you just don't sit down and say, I think I want to do this, I think I want to do that. What do you have? What data do you have that supports your decisions? If you say there's a problem, what's the magnitude of the problem? So these are things that you must set out and do in advance before you can say you have clear goals. So we'll continue today. And I had mentioned yesterday that the priorities have to be clear and you ensure that it is what is going to give you the results you are seeking. So if you have a list of activities that you want to do or programs that you want to do, you prioritize the programs. Which one will have high impact on the people and the environment and perhaps cost effective? You can have high impact activities that the resources you have available are not able to support you to achieve them. So those kind of priorities may be good, but that they can't be able to help. You can't be able to achieve them because you don't have the resources. And critical problems are those problems that are very high impact on human health. So if a problem does not have very high impact on human health, on the environment, then it should not be regarded as a priority activity to undertake. Now, you need to work with your team and you need to be able to agree on what needs to be done. If it's an agency, what you want done must be shared and agreed by all members of the team. The point I'm making is the priorities has to be agreed before you will move up, because you'll be expected to work as a team. So cooperation is essential within the organization and within organizations doing similar activities. In our case, when we were talking about national and subnational levels, then the local government level, cooperation is essential. Instead of saying, this is solely my work. Solely my work will not work because you will need the support of the next segment to be able to be effective. So cooperation from national agencies with state agencies, local government agencies, cooperation with non-state actors, the NGOs, the CBOs, the private sector, all of these people have a role to play. So the cooperative approach is recommended. Then you set realistic standards. If they are not realistic, as we said before, you're not likely to achieve them. Or you're likely to achieve it, but you waste resources in the process. So it's important that you set priorities that you can be able to achieve. The goals must be objective. The goals must be objective. Objectivity speaks to what you are set out to do that will solve a particular problem. You aim at solving a problem, and it's a problem that you need to be very clear about. And because resources are involved, you're always thinking of how feasible the program you have agreed to do is. If we look at goal objectives that are set without looking clearly at what will work and what will not work, you can begin the program and realize that you don't have the positive effect you expect on the people and the environment. If we move away from air pollution, we have water resources issues. Our largest reservoirs, natural reservoirs of water, are depleting. And most times we hear about dredging of our rivers. Dredging is a big and ambitious project to do. But how effective is it going to be even if you do it, and at what cost? So you look at what you need to do that will have the effect to see on the ground. Then the process itself, like dredging, how will you do it? How will you harvest the sand that is in these rivers? What technology will take the sand out without touching the boundaries of these streams? In any case, the sand is in those water bodies because the boundaries have been disturbed. So if you want to dredge, you want to look for that technology that will not further disturb the boundary. But if it will disturb the boundaries, you're just taking a remedial step that tomorrow you will find it come back. Because the very problem you want to solve, you will create even more. Maybe the area you are starting your work was not even used to, activities of heavy machines on the boundaries. But now your attempt to dredge has brought in machines that will further degrade the boundaries and create more channels for sand to get into the water body. So you must be clear on the objective you have set. You must be sure that it's something that is going to work. You must be sure that it's cost effective, and then you will attempt to go ahead and carry out the program. The issue of decentralization is also there, and this really applies to government agencies who have responsibility to ensure we have air quality. The example of national agencies working with state agencies and then at the local government, that approach is essential, but everybody must understand what needs to be done and agree that it is important to do it. And then the teams can work together to be able to achieve it. So decentralization is important if the scope of the project you want to achieve is large in terms of geographical coverage, where you need the support of other agencies or experts to be able to carry it out. Yeah, so I need to know that you're still there. Get to the chat box and let me know you're on the call. Just type I am on the call, your first name, and then add I am on the call. Yeah, so let's be sure that I'm talking to Samuel, yes. Stephen, yes. Ikum, John, yes. Agatha, I see you. Yeah. Yes, Inunsa. So let's go on. So okay, so laws and regulations. This is where you're thinking of how to set the standards. What do you, the emission reduction targets? If you want to set the targets, and what legal instrument is in place that you can leverage on? You may begin to do some things, and before you know it, an agency takes you to court. You're doing something that you're not permitted by law to do it. So you look at laws that are in place. If they are weak to support the program, you think of strengthening the legal framework before you embark on it. But if you have that in place, then you will be guided by the legal instruments that are in place. So goals and standards are related to air quality management, in different forms. What acceptable level of pollutant in the air can you permit? The limit of the amount that is emitting from the sources, is it observed? The limit on the amount of pollutants in a fuel or in fuel, for example, or any product of any kind, is it observed? Do people know about the limits at all? Those who are involved in the pollution, are they aware of limits that have been set by the legal instruments in place? If they are not, you need to be able to educate them so that they can be able to see where their activities should stop, where what they are giving off into the environment should not exceed. And like we said, research is very important, and it is from research that you can be able to know what is being generated, how it is, moving from one point to the other, and the effects on people and the environment. So you cannot ignore science. You must be able to uh, ensure that you have evidence, justifiable evidence that you can rely on. And when you embark on such studies, you have to be objective. You don't go into the studies with a predetermined result. You will go into the studies with an open mind so that whatever you see, you can work with. The methodologies have to be trusted. If you're using equipments to test pollution levels, the equipments must be in good working condition. It must be up to date enough. The precision of the equipments has to be taken note of so that the result you are picking from these experiments can be trusted. If your data cannot be trusted, if your data is not real, if your data does not reflect the current situation in the environment, that's a very faulty foundation to start. So we need to take note of that. Now we have two common types of air pollutants. The first category here, the common air pollutants. 6 critical pollutants in form of particulate matter. And you have them here: ground level ozone, carbon monoxide, sulfur dioxide, nitrogen dioxide, and we have lead. These have effects on human health, and they harm the environment and even our properties. So we need to understand that we have these pollutants. We need to understand their sources, what causes them. If you look at the 6 of them, carbon monoxide or carbon dioxide, for example, we have industries, we have burning of fossil fuels, we have all kinds of sources that emit this gas into the atmosphere. We also have different media in which it can be trapped and kept. And that is why climate scientists will emphasize that we should retain vegetation, particularly trees, have less disturbance of the soils, and then this media that I have mentioned, if they are preserved, the gas is trapped and then is kept from the effects that it would have caused to the environment. So on the other side, if you destroy vegetation, you encourage combustion of organic materials and promote industrialization without any protective measure, you will have this source of pollutant everywhere in the atmosphere, and that can affect people's lives. So these pollutants are harmful, and we need to have, limits that we can be able to keep them, so that we don't allow them to have so much effect on the people. Out there in developed countries, they have set up evaluation standards that periodically they are able to check to know how much of these gases people are exposed to. And where we don't do it, it becomes really worrisome. And at the individual level, what do you need to do to be able to see that you're not a contributor to the problem? I was talking to some students yesterday. We were talking about waste management, and we agreed that everybody has a role. It begins with individuals, families, communities, states, nations, regions, and it's every segment of this hierarchy has a role to play. The government can decide that this we will not be able to do this. We can't go and we can't exceed this limit. A national policy can come up, and then it stops people from taking certain actions that will promote the availability of certain pollutants in the air. And once the policies are enforced, you will have the result that you're expected to see. So it's important that we take note that as we think about how the air is affected by pollutants, we have roles at different levels in fixing the problem, because those who are creating the problem may not be just one segment. Some pollutants may be, with the degree of the problem that you're generating may be less compared to the next person, especially if you look at individuals and companies, some pollutants. But everybody has a stake. And then the second category is the hazardous air pollutants. These are toxic air pollutants, and they are oftenly very adverse to human health and the environment. You have them listed in the second bullet: benzene, gasoline, and the rest of it that is mentioned here. The stratospheric ozone layer, which is the layer of the atmosphere that shields us from the ultraviolet radiation from the sun, is degrading because we have ozone degrading substances or pollutants in the atmosphere. This is harmful to man, and it changes a lot of things. If we have time, we'll look a little more about this. The degradation of the ozone layer is caused by some of the pollutants that we talked about. Carbon dioxide is the chief of all the chlorofluorocarbons that cause this problem. It's a huge problem because once there's degradation of that layer of the atmosphere, the ultraviolet radiation will be incident on the earth. And it's radiation that is not expected to get into the earth freely. That's why nature, God made it that it should be that shield of the atmosphere. So when this is happening, you will begin to experience changes in the earth. And one of the changes that is obvious is these changes in our seasons. In this part of the world, we have the dry season, we have the rainy season. There are a lot of changes in the rainy season right now. Onset of rains is happening much, much later than what was heard of 40, 50 years ago. And then the same rain is ceasing earlier in the year. So the rainy period of the year is shrinking. Rain starts late and then ends very early. So the question is, if the trend continues and our agriculture relies on rain-fed agriculture, are we going to still produce? We may ask genetic scientists to be able to keep producing crops that their growing cycle is shorter and shorter. But how long can we continue to do this? So these are the problems that we face if we allow what is not natural to become the order of the day. Now, volatile organic compounds are also part of the pollutants that we're talking about in the air. Methane is one of them, and it's also a greenhouse gas that affects the ozone layer, though in a different degree compared to carbon dioxide. So all these are coming from activities that we engage in to be able to produce what we need. So in solving problems that man needs, other problems are created in the form of pollution. And you can see the magnitude of effect that you can see from methane. And it's deep, even though the ozone layer has recorded some improvement in recovery. Then in the last 2 years, results have shown a little recovery. But that recovery needs to be sustained before it can translate to a recovery in our seasons. So even though research shows that there's a recovery, less of the ultraviolet radiation is incident on the earth right now, but it has not translated to the immediate changes we want to see in our seasons, because the impact of what is already incident, the impact of what has been caused before is still being felt. And we can see how our weather and the seasons are changing. So, just like I said, the ozone layer recovery has been noted, but in some countries, they also make efforts to ensure that there is a decline in this volatile organic compounds. But not everywhere. Not all countries are involved in this. And if it is not all countries, the effect goes to the same source. We share the same atmosphere, and the pollutants can be felt between one location. They can be felt, they are not localized. When it gets into the air and there are effects depending on the pollutant, it can be felt over regions. So that of the atmosphere particularly is global. The effects of ozone layer depletion are global. And that is why climate change talks and conferences, there has been negotiations to see that the situation is improved upon. Those who live solely on production feel they have to produce to be able to keep their population in shape. And then by producing, these gases are emitted into the atmosphere. Those who are producing less are saying countries that are producing more are causing the problem for them, and they should support their recovery processes or adaptation measures to be able to cope with the situation. That has become political, and it is almost an endless discussion that happens every year. So you will look at the different examples that have been shown here. I'm trying to So climate change and air quality is just like I have explained. The pollutants, some that have effects on the atmospheric layer that shields us from the harmful radiation from the sun, creates the link between the changing climate and pollution. So the pollutants degrade the protective layer of the atmosphere and exposes us to radiation that can change things in the air. If we reduce or control emissions that we generate, then we will have a healthier portion of the atmosphere that protects us. So if we look at our energy sources or reduce demand for energy, which is almost not possible. But if we think of changing our energy sources from sources that emit more to sources that emit less, will be on the path to solving the problem. And that's why some schools of thought are promoting renewable energy, which has no effect on the climate. Attempts have now been made to harness solar energy to be able to produce the energy needs, respond to our energy needs. This is still work in progress, because where it is sufficient, the affordability of it for everyone is not yet there. So it's expensive, and it takes quite some money to set up to be able to provide energy, especially at the community level. At individual levels, some people have been able to do that, and they are able to enjoy energy that is safe and without much issues. So these are some of the things that can be looked at. If you look at the problem, what do you need to do to solve the problem? Are there alternatives? So for energy, we have solar energy as an alternative to burning of fossil fuels. We talk about gas. Nigeria has a lot of resources regarding gas, and we are exploring to be able to tap it and use it. But is it safe for the environment? That is the question. But nobody will listen because money is coming from it. One of the ways that we can look to our energy needs is exploring solar options, and we are seeing some results in that regard. Then the next thing is to monitor. Remember the circle. When you execute, you monitor. So air quality monitoring is a long-term assessment of pollutant levels in a particular area, and you do this to know what is in the environment and what is reducing or increasing. It's an integral part of the management systems, air quality management system. And why do you monitor? You want to assess the extent of the pollutant in the atmosphere. You want to also provide data on the extent of the presence of that pollutant in the atmosphere to whoever needs that information. You want to use that data to support the goals that you want to set. And that is why after monitoring, you may have to set or review your goals to be able to do things better than the way you did. It also evaluates the effectiveness of the control measures you have set in place. You set targets and you propose control measures that will keep the targets, make you achieve the targets. So when you do monitoring, it helps you to see whether your control measures are effective or not. Now, you can also provide information on air quality, the trend in air quality. In the 1990s, if you did the monitoring, what values will you see? In 2000, what was the trend? The values going up or they are going down? In the 2020s, what are the results and what can be done? So monitoring helps you to check if over time you have improvement or not. And then data is it provides data for modeling. Just like other fields, the models can be developed in air quality management, and they rely on evaluation data to be able to do that. Evaluation will also inform the next steps in research, what needs to be done. If you do an evaluation and discover that there are pollutants that still have high effects on people, it gives you the next step for the research that you need to do. Now, there are different methods of air quality management. This, you will look at it for information. Those of you with bias in these areas, they find this as starting points for further reading. And the methods are mentioned here. And you look at them, like I said, those with backgrounds in this area, chemistry, may understand this. My background is not around this, and this is just presented for you to take note that these are the methods that can be adopted in air quality monitoring, and the cost that is attached to it. You will note that this is information that has been done for quite some time now, and there's need for review and to seek what the information that is up to date. And let me pause here to take your contributions before we move forward. So the chat box is there. Let me see your responses. We have only 24 persons on the call this morning. Joy, be taking note of this so that we can know who is following. Yes, so let me take your comments. The class is very quiet. Okay, let me. So I've dropped a question in the chat box. Respond. Yes, there is a question in the chat box. Akpan is asking, regarding air quality, does the state regulator have the power to does the state regulator have the power? I'm trying to get to the chat. Does it have the power to establish standards? Yes, if that state agency is enabled, the state assembly enables that state agency through legislation. The agency can establish standards within the state. It will not have power beyond the state. But once that is enabled by law from the State House of Assembly, the agency has the power to regulate within the state. So I've asked a question. Are you aware of any air quality standards in our country? Akpan says yes, that there are regulations developed by NESTRIA. Any other response by federal ministry? Federal Ministry of Environmental. Are you sure of what you want to type? Freda, not sure we have a Ministry of Environmental. Alan says he's not aware. Akpan, if there is inconsistency between what is at the state level and the national level, that is not an issue. It may just indicate that there's a peculiar need or problem in that state that may not have national spread or is not recognized by those who are in charge of the national body. We had was it last year we were hearing of a problem in Port Harcourt? I can't, an air pollutant. People began to notice a pollutant. I can't remember exactly how it looked at and the way it was described. But a situation like that was peculiar to Port Harcourt. So if you have an agency, a regulatory agency in the state, because of the effect of what was being seen, the House of Assembly can empower that agency to be able to regulate, get to the companies, compel them to do what is right. And why there is need for legal backing is that the person who is involved in, who is polluting, can be aggrieved and take you to court. And the courts they will not know any other, what they know is the law. So if there's an enabling instrument, an enabling law, then the agency will have the power to regulate based on the provisions of the law. So there can be differences in what is going on in the state compared to the national level. And not because they may not be willing to work together, but the peculiarity of the problem in a particular location can warrant the change in policy, or they can warrant a law that may not be envisaged at the national level. Carrying out a survey on a particular challenge, I believe, involves money. If you discover a challenge you wish to carry out a survey and you don't have the money, what would you advise? Just like any other thing that you may desire to do, if you don't have the money, it's not done. You have to have the money to be able to do it. Okay. Yes, Freda, we have seen what you meant. National Environment, National Air Quality Policy. Which agency? Because in our country, I think NESRIA is the agency, the body at the national level. And it has developed different, not just air quality, different policies regarding environmental management, particularly to reduce the effects of the environmental issues that we have on people. Then Nigeria's National Ambient Air Quality Standards define legal limits for major pollutants like this. Okay, right. So that's a document to reference. So you can get that out and share with the class. Is there any proper agreement between the state and the federal agencies? Depending on what issue is on the table to deal with. But like I said, collaboration is essential and is expected. So I think at one point I got materials from NESRIA, and they have quite a number of policies in place to keep our environment safe. So it's good to seek these policies, the ones that are relevant to air quality would be useful to you as you expand your understanding on this. So passive and active sampling. The underlying principle of passive sampling is flow of contaminant molecules or ions from one medium onto another. These are the ways in which you can evaluate the amount of a particular pollutant in the air. So we're looking at methods now. Which method is more feasible for you to adopt in evaluating a particular pollutant? So airborne gases and vapors are collected by a physical process such as diffusion through static air layer or permeation through a membrane. I believe this uses the process of diffusion, where you check the point source where the pollutant is coming from, and then you move away from the point source and then do some checks to see how far the pollutant can be felt away from the source. And that tells you the degree of its movement from one location to the other, and whether as it moves away from the source, the concentration and effect on people is reducing or it's the same. So these are methods that can be adopted. You need to note them. These are methods that can be adopted. So if any of you is going into studies like this, you will look at which method you should use. Passive air sampling is frequently used in monitoring. And like I said, those in chemistry with chemistry background understand the details on how these methods are applied, what lab or situation or equipment will be used for you to be able to do the evaluation. So it uses what is called settle plates, and it does not disrupt the immediate environment. So, like I said, my understanding of these methods, it depends on the pollutant that you are investigating, the nature of that pollutant, and then the cost also would determine which method is feasible for you to use. Active sampling uses the air sampling pump to be able to measure the amount of a pollutant in the air. So you will see details of the pump. They don't require air movement within them. And active sampling for gases and vapors is personal unsolvent tubes. And these are also details that those in chemistry will understand much better. So this is a diagram of a sampling pump. So those who use it will understand that better. So this integrated versus continuous measurements, it's a form of monitoring of pollutants in the air, and it also involves collecting pollutant concentrations continuously over a period of time. This is with respect to time, that the pollutant is collected over or measured over a particular time to be able to establish the amount in the air. I think generally one of measurements may not be very accurate. If it is a research, you take a number of measurements and you have a mean to be able to say this is the amount of the pollutant in the air at this point in time. So these are setups out there. These are setups that are used for this monitoring, pictures of there are technologies or setups that are used for monitoring. And so you see the different gases that are tracked and the various measurements when monitoring is ongoing. And sensors are also used, and this can be another form of, tracking pollutants in the atmosphere. So it provides a source of energy to illuminate the objects that you're observing. Active sensors emit radiation in the direction of the target to be investigated. So they use radiation in measuring particular pollutants in the air. And the two types are here, passive and active sensors. The passive sensors are able to detect natural energy that is emitted or reflected by an object that is being observed. And so, like radiation from the sun, apart from ultraviolet radiation that is studied much because of its effect on the climate of the earth. The sensors use sun rays to be able to, in tracking what amount of a pollutant is in the air. So these are different options. Most of them may not be relevant to us because we do not have those technologies in place, but they are mentioned so that you will know this is what goes on. Out there where there are facilities, people that are in these fields have opportunity to access labs that have equipments that they can use for this. I think here we have people, I think in physics, in physics, that attempt air quality measurements, and you can explore what we have locally and be able to relate it with the information that is shared by these materials. We, as a project, these materials were developed to have international relevance, and that is why we're sharing some of the information that is contained in the slides here. A number of them may not be things that we have, or if we do have them, I'm not aware of them. So you take note and explore. If you have interest in studying more about this, you explore what we have and how it's able to work, the results it can be able to give us. So types of emissions, point sources, this is easy to relate with, where the pollutant is emitted from. If it is a company and it's emitting maybe into the atmosphere, the point where it is sent into the atmosphere is the point source. So sometimes it's fixed, sometimes it is not. And in studying pollution, like I mentioned earlier, you need to know how much is emitted from a source, and then you need to check how much is able to move away from the source, and then the effect of people around the source and those who are away from the source. The best approach and the safest approach to adopt is to avoid emissions or control them to ensure that the people are not exposed to them. So that is the best, but in practice, we see that when people embark on the need to produce, they are not mindful of what will happen to people. They are mindful of the products that they want to see. So that is the challenge with emissions. And we need to note, and if there's regulation, we ensure that we are able to reduce or check what is able to reduce the emissions from the point source. So you build in technologies that can reduce or take care of the pollutant and not let it into the environment. So point sources and then fugitive sources. There are emissions that distribute spatially over a wide area. They are not confined to a specific discharge point. They originate in operations where exhausts are not captured and pass through a particular medium. A moving car, for example, I don't know if this would be the best example, but a moving car, for example, emits through the exhaust. And as it is moving, whatever pollutant that is coming out of it is distributed over the space in which the car is moving. So it is not static and it's not, you cannot say this is where it is coming from, except the car is not moving. And if this car is moving, it depends on the distance that it moves. So you cannot tie it to a particular point. As long as the car is moving, it's distributed over a wide area. This looks close to what the first bullet is talking about. So they have potential for much greater ground level impact because of the widespread. Now, some are volatile and some are in particulate form. Volatile, there may be a form of gases, but the particles also are there. So it can be in particulate form and it can be in form of a gas. And other contaminants may also be associated with this, depending on the type of emission. Then open burning of solid wastes and other hazardous or non-hazardous substances can also have this effect, depending on the extent of what is burnt and over what space it is burning. So it is important to know we have point sources of these emissions, and we have the fugitive emissions. Then emission monitoring. monitoring what is already in the atmosphere. It's carried out to collect information for the design and operation of control systems by regulatory agencies. You may have different methods to adopt this, but the whole essence of monitoring is to determine the flow rate of a particular pollutant, how much of it is in the atmosphere. And this is where the data that you need to be able to set your goals comes from. This is where the effect of the pollutant is also determined. So emissions are measured to determine the amount of the pollutant in the air, in what form the pollutant, whether it's a gas or it's a particle, it's in particulate form, and then where it is being emitted from, and what sort of emission it is. Is it from industries? Is it from vehicles? Is it from other sources? Monitoring will help you to be able to determine which source. The measurements of emissions can be used to understand the relative importance of a given source compared to other sources, and in developing emission inventories. When you monitor, you're able to know the effect of different sources of a pollutant. Is it coming from burning of materials? Is it coming from an industry? Which is, what type of pollutant is this and what effect does it have? In terms of spread, which source is able to move or have more effect compared to others? So monitoring is done, can be done by the government, can be done by an industry, and it is expensive, as we said, if it is large scale, and if it is not the large scale, then even at an industry or personal level, people can monitor what they are, the effect of what they're having around them. But most times in countries like ours, most of this is left to the government to be able to do if they give attention to it. So measurements can be taken over a short period of time, or they can be taken over a long period of time. If it is continuous monitoring. In any case, these measurements give information on the effect of a particular pollutant and what needs to be done. Now, from the measurements, an inventory can be developed. You have a database of the kinds of pollutants in a particular area, their sources, and then how much of it is in the air, what sort of discharge method are these pollutants released into the atmospheres. These inventories help in developing targets for regulatory agencies. So they are able to have target based on the information that they're having from the data they have kept over time. So in other words, you don't take measurements and throw them away. So measurements that have been taken over time, over decades, can be kept, and that becomes a database that can be referenced and utilized for air quality management. So this is more on inventories. It includes estimates of emissions from various pollution sources in a particular geographical area. It should include all pollutants associated with air quality. You're able to do that, and that we provide a database for a broad range of pollutants in that area. An emissions factor is a representative value that attempts to relate the quantity of a pollutant emitted with an activity level associated with the emission of the pollutant. This speaks for the amount of a particular pollutant in the atmosphere and the source or what triggers the emission. Such factors facilitate estimation of emissions from various sources of air pollutants. So we have, I think, a slide or two on mathematical modeling. Modeling also is used to be able to estimate the relationship between sources of pollutants and their effects on air quality. This information can also be useful to managers if it is done appropriately. So models also use meteorological data, particularly with as it relates to weather. Meteorological data can be a good source of information to track emissions in a particular area. So the models are designed to characterize primary pollutants, those that are emitted directly into the atmosphere. And then some models also characterize secondary pollutants that are formed as a result of chemical reactions. So when these pollutants get into the atmosphere and perhaps react with other gases, new products are formed other than what was emitted into the atmosphere. So those are the secondary pollutants. But the primary ones are those directly emitted into the atmosphere from their sources. So modeling tracks both types of emissions. And these are sources of the Environmental Protection Agency and the activities in the US. So, yes, are there questions or remarks that we can take? The chat box is there, you can utilize it. Okay, yes, Simeon, yes, crushing of stones, good examples of fugitive sources. Yes, at the current, those of you around where mining is going on, we hear that even in Benue State, we have locations where a lot of this is going on. Crushing of stones can generate dust, and this dust may even contain some substances that can cause pollution beyond just dust. So if some of you are interested, you may want to check what sort of pollutants are emitted based on these activities that are going on around us. You would have been, you'll be able to do the people around these areas a lot of good by providing information on the effects of what is going on around them. Because what we see these companies do, they just go for the minerals, whatever they are seeking, and have less attention to the environment in which we live. So this is important to note and to explore if you can be able to check the effects of what's going on in these areas where mining is taking place now. Somebody said he's not hearing me. I don't know if you're able to hear me now. I think my data connection is still active and good enough. So if you're close to where mining is happening, can you tell us what it looks like in terms of air pollution? Some of you who are close to areas where these companies are mining right now, you can indicate and let us know if you're close to any of these areas where mining activities are going on. I can't see any hand yet, so it looks like none of us is close to any of these areas. Yes, primary and secondary pollutants that I mentioned in the slide I just shared. The primary sources are talking about the point where the pollutant is emitted. Then the secondary sources, when the emission from the primary source gets into the atmosphere, is it able to react with other gases if it's in gaseous form? And if it reacts, is there another product or another pollutant arising from that? If it does, those are the secondary sources. While the primary sources are the points where the pollutant is emitted either from a company or a production activity that may be taking place, or even burning of fossil fuels or burning of materials. Some people will gather maybe plastic materials and set fire in order to get rid of them. When you do that, there are emissions, and if they have harm to people and then the environment, then it means they can be regarded as pollutants in the air. So when they get to the atmosphere, are they reacting with other gases? Like carbon, when carbon gets into the atmosphere, it reacts with other molecules of oxygen, and it can become CO2. And that is also a gas that has effect. So what we're saying is, when these sources are emitted and they're in the forms that can interact with other atmospheric gases, the possibility of other substances arising from there is there. So the primary sources are those points where the emission takes place. But the result of their interaction with other pollutants is what is regarded as the secondary source. So if we do not have comments, I will be stopping here. Dr. Adi will continue, and he will look at soil, he will look at water. Yeah, I will share the materials I have on the platform. If he has something to edit, we are sharing the same PowerPoint. If he has something to edit and add to it, he will do it. But after now, I will share the materials I have got on this aspect with you on the platform. So let me attempt to share that on the class platform now. PGD. So the materials will include information on interim guidelines and standards for industrial effluent gases and emissions and noise limits in Nigeria. That will help you with information on what is the permissible limits of some of these pollutants in the atmosphere and also in water. Just for your reference, the other aspects are on soil, which Dr. Adi will be able to handle. So let me share. I want to be able to zip the documents before I share. Okay, almost there. Okay, so I've been able to send it over. So you will look at it, and then Dr. Adi will continue from where I've stopped in the afternoon. Did he come to the class yesterday? Dr. Adi attended was in the afternoon class. Oh. Okay, he had network issues. Okay. Yeah, we talked this morning. So I also wasn't able to hear him very well. And his network in his location is not good. I believe he will change his, either change his location or improve on his network source so that he will be with you this afternoon and for the remaining days. So thank you very much, and do have a great day. So the class rep is it Akpan? Remind me of the rep again. And do you have an assistant? Who is the class rep? Please remind me. Okay, Livinus. Chenenge is the class rep. Okay, Agatha. Chenenge class rep, and then Agatha is the assistant. Okay, thank you. So the class rep and assistant, which way is easier now? Get to the platform and try to send your numbers to me. I'll put my number here now. So you will send me a WhatsApp chat so that if I have information, I can send to the class. I will share my contact now. My WhatsApp number. So it's shared now. The class rep and assistant, take note of it and send me class chat. Chat. Class rep ENS 709-2026. So that I can take note of it. If there's anything I need to get to the class, I'll send it through you. Okay, thank you, and do have a great day. Bye-bye.